Hello everyone, welcome to the computer aided drawing course. In today's lecture we're going to discuss the tangencies, which is one of the important topics of the engineering drawing, and the key idea here or the objective is just to show you how we can draw curve that or arc that are tangent to two other objects like two other circles or two other lines. And this is drawing the curves actually or the tangencies. It requires some skills or not skills. It is like there is a procedure or there is a concept, engineering concept that we have to stick with to or stick to create the or draw tangencies in two-dimensional sketches, especially. So how we can create or draw tangencies in two-dimensional sketches, and this is the objective of this today's lecture. As we discussed before, that any two-dimensional sketch, whatever it is, it consists of set of lines, circles, or arcs, like this black arc already shown here. Like this arc number 3 is already tangent to these two circles, circle 1 and circle 2. So to draw a circle, as we discussed before, that we should have two information, two things that we should know so we could able to draw a circle. The first thing, how much is the diameter or the radius of this circle. The second thing is where is the location of the center point of the circle. That before drawing the circle or even asking how much is the diameter or the radius of this circle, we have to ask where is the center point of the circle first. So for example, if I ask you to draw this circle 1, you're gonna locate a center point, draw the circle. The same thing, you're gonna locate the center point of the second circle with respect to the location of this the center point of the first circle to draw the second circle. Then that's it. You're just gonna open the canvas and draw, fix at the center point with the metal tip of the canvas and draw the circle. Very simple. But how about the arc? This arc, it is tangent to these two circles as already shown here. It is tangent at point A and it is tangent at point B, right? And the radius of this circle is already given by 30 millimeter. But how about the center point? It is not necessary for an arc that is tangent to two objects that the center it will be given. Or as I mentioned, the arc is just a portion of the circle. It is a part of a circle. So what does it mean? It means that to draw the arc, looks like you're gonna use the same tool and you're gonna do the same concept that we used to do for drawing a circle. Like you have to locate the center point first, then you're gonna open the canvas with the radius which is 30 millimeter, and simply you're gonna draw the circle or the arc, which will be automatically tangent to the two circles. But the problem is, in terms of the practical engineering drawing, that in case that we have an arc that is tangent to two circles, we are not specifying where it should be the center point of this arc. It means that if you are given an exercise and there is some tangencies, the center point will not be given to you. You have to locate where it should be the center point based on what? Based on the tangency concept. And this is what we're going to discuss. We're going to show you how you locate the center point of a curve or an arc that is tangent to two objects. These two objects would be two circles, two lines, or one circle and one line from other side. But anyway, a curve it should have two tangencies, 2 points of tangent, like this point and this point of tangent here. So given the tangencies that already given to you, in addition to the radius, and the center of the curve will not be given, how we look at the center of this curve so we could able to draw this curve? This is what we are going to discuss through today's lecture. Make sense? So for example, these are some examples here. Like in this case, we do have, this is the curve which is 20 with a radius 20 millimeter that is tangent to two lines. These two lines, the first line, the second line. So first of all, you have to locate what are the objects that the curve is tangent to. It is tangent to two lines in this case. Make sense? Here, it is tangent also to two lines, like there should be one big line here and there should be another line here, and it is tangent to these two lines as already given. The same thing, this curve, there is a very small curve here that is tangent to two lines, one line and another line, and is tangent for both of them. As you can observe, for all of these cases, do you think that the center, or do you know where is the center point of this curve? This curve, it should be like a complete circle. So we have to locate a center point. We fix from this center point with the metal tip of the compass, open the compass by the 20 millimeter, draw the circle. Very simple. But the problem is, where is the center point? It is not given. Where is the center point of this one? Where is the center point? Someone gonna say that it should be somewhere in this region. Yes, it is, should be somewhere in this region, but where exactly? We don't know. Someone gonna say, okay, I'm just gonna try. I'm just gonna fix here and try if it's gonna tangent or not. Then I'm just gonna shift a little bit to the right. So you're gonna spend the whole day to find or locate the center point. So the question is how we can locate the center point of a curve that is tangent to two lines. In this case, this is what we are going to discuss. Another thing for these cases, this is a curve that is tangent to two circles. This is one circle and there is another circle, and it is tangent at these 2 points. This is point of tangency. There is another point of tangency here. The same thing here. It is tangent from this point, tangent from this point. I'm talking about this curve. So I do have two curves that tangent to two circles. So this is the other case. The previous example that we had, curve that tangent to lines. Here, curve that tangent to two circles, right? Like in this case, this curve is tangent to these two circles in these 2 points, and this curve is tangent to these two circles at these 2 points. So the question is how we can draw these tangencies. How can we draw these arcs or curves that tangent to two circles, right? Because where it should be the center point of this R40, this is the radius of this curve, it is already given, but where is the center point? We have no clue, but it should be somewhere in this region. We are pretty sure of that. The same thing, this one, it should be somewhere here. But where exactly, we have no clue. We have to figure out where it should be the center points. This is what we have to do. The same thing for all of these arcs. In this case, we do have a circle, we do have a line, and we would like to draw a curve that is, with a radius 40 that is tangent to a line and a circle. So in general, the curve, it should be tangent to two things, either two lines, or two circles, or line and a circle. So how we can specify the idea just to locate the center point. If we locate the center point of the arc or the curve, simply fix at this point, open the compass with the radius of the curve, simply you're gonna end up with the curve. But there are some challenges here that we have to stick to a procedure that I'm going to explain. I'm gonna show you how we can locate this center point, and your calculations and your dimensioning or your measurements should be accurate 100%. So you're gonna end up with the perfect tangency. Because for example, for some reason, if you messed up with the dimensions, you probably gonna find that this curve, when you try, after you locate the center, you locate it, try to draw the curve, it will not be tangent. Because the tangency, it means that the curve, it should be touching the line in just 1 point. The curve, it should be touching the circle in just 1 point. So it is tricky. So it needs practice, and your dimensions, it should be accurate, as I'm gonna show you through this lecture. So the question is how we can create these tangencies. I'm just gonna use another sheet here just to explain to you. Then I'm gonna show you by hand. I'm gonna work with my hand. Then I'm gonna show you how we can draw these tangencies for today's lecture. So in the beginning, let us consider the simplest case, like you do have, or the first case that you'd have just two lines, one line in this way, and there is another line. Whatever the angle between them, we would like just to draw a curve that is tangent to two lines. So generally, the procedure depends on, to draw a curve, we have to locate the center point in general. To locate the center point, first of all, you have to draw two lines. Let us assume that this is the drawing that we would like to create. Like we would have a curve here, and the radius, let's say, of this curve R equals 20, like R20, for example. So let us repeat this shape here on the left. So first of all, you have to draw the objects that already tangent to the curve, which are the two lines. So in the beginning, I'm just gonna draw a horizontal line, then I draw the inclined line, I end up with this similar two lines. Then I need to draw the curve. So first of all, what you're gonna do in the beginning, you're just gonna use, let me use here. In the beginning, you have to draw two lines. one line that is parallel to the first line but normal, with a normal distance equal to the radius of the curve. How much is the radius of the curve? It is 20. So what you're gonna do, you're just gonna draw a very light line, vertical, using arrosto, that is normal or perpendicular. This angle you have to be pretty sure that it is exactly 90 degrees. Normal to the first line, and over this line, you're gonna measure 20 millimeter distance and mark a point. Then you're gonna, from this point, you're gonna use arrosto to draw a horizontal line that is completely parallel to the first line. Make sure that this normal distance between them, it should equal to the radius. Typically, if the radius 20, it should be 20, 30, it should be 30, and so on. This is the first step. Repeat the same for the other line. So, first, from any point, draw a line that is perpendicular to the first line and make sure that it should be completely perpendicular. The accuracy of the dimensioning and the measurement are very important. If you messed up with anything, if your calculation and measurements are not accurate, the curve, if you spend the whole day, won't gonna be touching the two lines. Make sense? So make sure that this one is completely perpendicular using the arrosto as we discussed before and we practice in the class, and as I'm gonna show you by hand how we're gonna do it through this lecture. Your objective, draw the line, then measure 20 millimeter, which should be the same radius size of the curve. I'm gonna measure 20 millimeter, mark a point. Then from this point, you're just gonna draw a line that should be completely parallel to the other line. So I've drawn two lines, one parallel to the first line, one parallel to the other line, with a normal distance between them equal to the radius of the curve, which is already given by 20. Each one of these lines is known as locus. Locus, it means that the center point that we are seeking a certain point of this curve. That the center point of this curve, it should be located over this line. Also, the center point, it should be located over somewhere over this line. Make sense? So definitely the center point that we are seeking will be automatically the point of intersection of these two lines. This is gonna be the center point. Very simple. Once we locate the center point, you can simply open the compass with the radius, which is 20, and fix the metal tip here and simply draw the curve. If you open the compass with the 20, exactly 20, and your measurements, it means that this distance is exactly 20. If this line exactly parallel to this line exactly parallel to this line, and this distance exactly 20, and you fix it this correct location of the intersection point and try to draw the curve, it will be perfectly tangent to the two lines. And for this case, we're already getting the tangency for the curve that is tangent to two lines. So simply, generally, in case that would have a curve that is tangent to two lines, simply we have to locate the center point. How? We have to draw two loci. One locus that is parallel to the first line, another locus that is parallel to the second line. The intersection of these two loci, this gives us the center point of the curve. This is one locus, this is a second locus. Both of them are two loci intersecting together at a point. This should give us the center point, then we can draw the curve. Simply. Make sense? And the normal distance between these two new parallel lines should be 20. And in terms of engineering drawing, these two parallel lines, the green lines, are not exist in the real drawing. The exact drawing is this one. So what does it mean? All of these green things, all of these green lines, I use them to assist me to locate the center point. So what does it mean this? It means that they shouldn't be in the drawing after you finish. So you'd have two options, as we discussed many times before. Either to draw, then you have to erase them using the eraser, you're gonna remove them. And in this case, you're already spending time or wasting time. Or the other option, just to draw this, use this line and make sure that they are very light, barely seen in the drawing sheet. So in this case, there is no need to erase them, and that is fine to leave them there. Make sense? So this is for the first case, and that we do have a curve that is parallel to two lines. The key idea that is tangent to two lines, the key idea just to draw two lines parallel to the original given line. How about if we do have a curve that is tangent to two circles? Like we do have one small circle, for example, in this case, and we do have another big circle. It looks like a watermelon, but anyway, In case that we'd have like two circles, and we would like to set up a curve that is tangent to these two circles in this case. This is the curve. And let us assume that the radius of this curve is 40 and the radius of this circle is, let's say, 20, and the radius of this circle it is 30, for example, or 40 or 50. Anyway, make sense? So in total we do have like these cases. So this curve is tangent to these two circles, and it is tangent to these two circles at two tangent points. These are the point of the tangency between the curve and this circle, the curve and the big circle, right? So to draw the curve, we have to draw the two circles first. So assume that this is the drawing, and I'm gonna repeat it again here. So this is, first of all, I'm just gonna draw the first small circle, then I'm gonna draw the big circle here. Make sense? Then your objective is just to use this data to locate the center point of this curve. So how we can locate the center point? If I ask you, just stick to the procedure that I'm going to explain here. If I ask you where it should be the center point of this curve, is it gonna be above or below? It should be above. It should be somewhere in this region, right? But where exactly, we have no clue, because if you fix with the metal tip here, you can easily draw a curve, this curve, which is R40, right? Then I'm gonna use the center of this circle and a center of this, the center of the other circle, to end up with to draw two curves here. Each one of these two curves should be locus to the center point, as we did here. We draw one line, one locus. We draw another line, another locus. Both of them, their intersection point, it gives us the center point. We have to do the same here. For the curves that tangent to circle, we're gonna use the centers of the circle to draw one curve, and the center of the other circle to draw another curve, in such a way that they are going to intersect in a point. The point of intersection, it should be the center point of the curve. Make sense? But the question is, how much is the curve that I should draw from this center point? I mean, I'm talking about the radius. How much is the radius of the other curve that I should draw from this center point? So we have to do some calculations here. For example, in the beginning, you're just gonna ask you three questions. Very simple three questions to locate, to identify the radius that you should use to draw the two loci, or the two curves that is gonna be intersecting at the center point. So three questions. The first question is, you have to ask yourself where it should be the center of the curve, above or below, right or left. Just a tentative position, approximate position where it should be. It should be somewhere in this region. Make sense? This is the first question. The second question, just mark any point. Assume that this is the sheet that is already, the exam sheet that is already given to you, and the one that is blue, this is your drawing sheet. So mark a point anywhere. Then try to move. Your objective is just to ask yourself how much is the distance in terms of the radius of the curve, in terms of the radius of the circle. If you try the distance between the center point of this curve and the center point of the small circle, how much it is. If you would like, so if you just connect a line between these two centers, according to the geometries that you had in the high school before, and the trigonometric concepts, that this line that we connect between the two centers, it should go over the tangent point, because these two curves are tangent together. This curve is tangent to the circle. So what is the length of this line? It should be the radius of the small circle plus the radius of the curve itself. So it should be like 20, because the radius here is 20, plus 40. So what does it mean? It means that if you fix with the metal tip here and draw and open the canvas with 60 and draw a curve, this is gonna give us the first locus. That it should go over the center point that we doesn't know where it is. Then, let us repeat the same from the other side. From this center, if you try to connect a line to the other center, it should go over the tangent point here, right? From the concept of the tangency, right? So if I ask you how long is this distance, or what is the length of this line, it should be the 40 plus the 50, which it gives us in total the 90. So it means that if you fix from this center point and open the canvas with 90, this is gonna give us another locus. The intersection of these two loci, the intersection of this line, this curve that you're gonna get from this center to this curve that you're gonna get from this center, this gives us the center point that we are seeking for the curve. Once we look at the center point, we're gonna fix with the metal tip here, draw a curve. Very simple. So as you can see here, in this case, we are adding the radius to the radius of the curve. We are adding the radius of the circle to the radius of the curve. Make sense? So what I'm gonna do here, simply from this center, I'm just gonna open the canvas by the sum of the two radii, the sum of this radius plus this radius, which is 60, and draw a curve. Then from this center, I'm gonna open the canvas with the sum of the two radius. The two radii, 50 plus 40 gives 90. Open, fix here, open with 90, give the center point, fix here, and open the canvas with the 40 to draw the curve. Then you can end up with the curve. If your drawing is accurate and net, you're gonna end up with a perfect tangency between the two circles. Make sense? So the question is it all the time we add the radius together, it means that 20 plus 20? No. In some cases, we would have to add the radius or sum this radii of the curve and the radius of the circle. In some other cases, we would subtract. So how we can judge? Another example that in which we have to subtract the radius, for example, like let us assume that we do have this circle and there is another circle here. And we do have this curve. This curve is tangent to the two circles, but at two different points, like two different concepts, kind of. Like it is tangent, this curve is tangent to this circle at this point, and this is the other tangent point to the curve, between the curve and this circle. And there should be definitely the center. This is the center of the first circle, the big circle, and the small circle. So if I ask you, let us give just numbers here. Let us assume that the radius of this one is just 60, and the radius of this circle is 20, and the radius of this one is 40. So if I ask you where it should be the radius of the curve, is it gonna be above or below? Here, it should be definitely over this area, right? Because the curve going down in this way, that rotates in this way, right? So it means that it should have a center here, somewhere, not exactly at this point that I located it, but somewhere. That just approximate location or tentative location for this center. Then if I ask you to move, or how much is the distance between this center to this center? It's gonna be the difference between the radius of the 60 and the radius of the circle. How did I know? Simply, if you draw this line, how long is this line? In the beginning, how much is the distance from this center to this tangent point? How much is this distance? This distance, it should be the radius of the curve, because if this is the center point of the curve, this distance, very long distance, it should be 60, right? So how about the short distance, which is this one? It should be 60 negative this small portion. This small portion is the 20. So it means that this distance should be the 60 negative 20. Here we are subtracting the radii. But how about this one? If I ask you how much is the distance from the center to the center, it's gonna be the 60 plus the 40. In total, it's gonna be 100. Here we are adding 40 plus 60. So in general, in some cases, we would add the two radii together. In some other cases, we would subtract them to end up with one locus and another locus to intersect together to end up with the center point of the curve. So how we can figure it out directly? You're just gonna ask yourself very simple questions. I'm gonna give you another approach that you can identify the values of the radii. Is it gonna be the sum or the difference that you're gonna use for drawing the curves to locate the center point? Just simple question. First of all, the question that we discussed before, where is the location of the center point? Where the center point should be located? It should be located somewhere above here. Then, if I ask you to move from the center to the center of this curve is tangent to these circles, right? How about if we have a third circle here and it has a center? I will not use this center for anything regarding this curve. Why? This curve is not tangent to this circle. So you have to locate which circles that already tangent to the curve, and you're gonna use their centers, right? So it means that I have to use this center to draw one curve, use this center to draw another curve. Make sense? But the question is, so the first question you should ask, where is the center point? It's gonna be somewhere above. Then you're just gonna ask yourself, if you try to move from the center to the center of this curve, are we gonna go over the tangent point? The tangent point of the curve to the circle will be down here, right? If we try to move from this center to this center, are we gonna go over this tangent point? No. We will not pass over this tangent point. So what does it mean? It means that we have to subtract. If this is the case, if you try to connect a line between the two centers and this line is not going over the tangent point, you are going to subtract the radius of the circle from the radius of the curve, or the radius of the curve from the radius of the circle. In many cases, you're just gonna subtract the biggest from the smaller from the bigger value, right? Like here, I do have 20, I do have 60, so it's gonna be 60 negative 20 gives 40. This should be the radius that I'm gonna use to draw a curve here. This curve, when you fix with the metal tip, you're gonna draw a curve with the radius 40, the difference. Why? Because when I did a draw, this is a very simple approach. Just draw a line or try to move from the center to the other center. Are you gonna go over the tangent point? No, so take the difference. How about this case? If you try to go from this center to this center, are you gonna go over the tangent point? Yes, this is the tangent point. This is the tangent point. Right? So I'm gonna go over the tangent point. In this way, you have to sum the two already. So it's gonna be this radius is 40, this radius is 60. So I have to open the comes with 100, but here I'm gonna open the comes with 40. So to locate the center, if you open the comes with 40 and fix with the metal tip here, draw an arc. This is the first locus. Then you're gonna, from this center, you're gonna fix with the metal tip, open the comes with 100, which is the sum of the radii. Fix and draw, fix here and draw another curve. They're gonna intersect at a point. This point definitely is gonna be the center point of the curve that we are seeking. Then from this center point, you can draw a curve with the radius 60. It's gonna be completely tangent as long as your dimensions are accurate and measurements are accurate. Make sense? So this is simply how we can draw a curve that is tangent to two circles, and this is how we can draw a curve that is tangent to two lines. For the two lines, we have to draw a line that is parallel to the original lines. For the circles, we have to draw arcs from the centers of the two circles that already tangent to the given curve. This is all why we are drawing these curves and lines to intersect together to locate the center point of the curve. Once we find the center point of the curve, we can easily draw it, right? But and this is the key idea of the tangencies, because in terms of engineering drawing and in many of the applications, and if you can open any engineering drawing, the curves, we just give their radius, their radii, and we are not specifying where is the center point of a curve. Since it is tangent, so you should know exactly how you can locate the tangent, the center point, so you could draw this arc or this curve based on the concept of the tangencies. So this is how we can do it by hand. Over AutoCAD is gonna be much more easy because it is a software, so AutoCAD doing all of these steps directly using a very simple command which is known as the fillet. This is what we're gonna discuss in the AutoCAD in the next meeting. But in today's lecture, we're gonna have practice, hand practice over the tangencies. So that's why in today's lecture, we're gonna work by hand. So make sure that you already have all the tools with you, the pencil, the Arrow triangle, the razor, the compass, because we're gonna use them for today's exercise, right? So in today's exercise, the objective is just to show you how we can draw these examples here. How we can draw a curve that is tangent to two lines, a curve that is tangent to two lines with an angle of 45 degree, or I mean less than 90 degree, and another angle that is bigger than 90 degree, which is and this is the radius of the curve. And in these different examples of arcs or curves that tangent to two lines, also we're gonna consider that we do have curves that tangent to two circles with different situations of tangencies, and the mixed case that you do have a circle that is tangent to line. I'm just gonna show you now how we can do it by hand. I'm gonna do it by my hand, and physically I'm gonna show you how we can create these or do these tangencies by hand. Then there are two examples here. This one is explained in detail over the slide, step by step, what you have to draw. If you stick to these steps, you're gonna know exactly how we can regenerate again this drawing. This is the given drawing, and we have to repeat it again, sticking to the dimension. So as you can see, which is very similar to the thing that we did the previous meetings before, but the previous meeting we had like some simple lines, some circles, but as arcs or curves like this one, this is a curve. This is not a complete circle, this is a curve. This is R5, it is another curve. So many of these curves that we already have their center points, and many of them we don't have their center point. So how we can look at the center point? We have to use the concept and the things of the tangencies that we just explained. For the case that you already have a curve that is tangent to two circle, or curve tangent to two lines, or tangent to one line and circle. In case that we have one line, a circle, and a circle, for the line you're gonna draw a line that is parallel to the first line, and from the center of this circle you're just gonna draw an arc that equal to the sum, because if you move from the center to the center, we're gonna go over the tangent point, so we're gonna sum from the sum of the radius. We're gonna draw an arc and from this center, and we're gonna draw a line that is parallel to this line. We're gonna end up with the center point to draw a curve. So generally, in case that you have a curve that is tangent to line, draw a line that is parallel to this line with a normal distance equal to the radius of this line, which is 40 in this case. In case that you do have a curve that is tangent, it is tangent from this side to a line, it is tangent from this side to a circle. So I'm gonna use the center of the circle to draw a curve, with the sum or the difference of the radii depends on the based on the approach that I just explained to you. To locate the center point, then you can draw the curve. All of these examples, I'm gonna explain them in details, but I'm gonna skip this one. It is already explained here with step by step how you can regenerate this drawing again based on the concept of the tangents that we just explained. Then after that, I'm gonna explain in detail how we can regenerate or redraw this shape again by hand based on the concepts of the tangencies. So I'm gonna continue the video, but I'm gonna move now to the hand drawing. I'm gonna show you the previous examples in addition to the simple cases of lines, the curves, tangent to line and circles. Then I'm gonna move to this example. Hello everyone, now we're gonna consider these examples, and I'm gonna show you how we can create these or draw these tangencies by hand. And I'm gonna show you this physically using these tools. Then I'm gonna consider this example here for this two-dimensional sketch and how we can draw this one using the concepts of the tangencies that we explained by hand. Right, so let us start with these simple shapes and how we can draw the tangencies of or these curves that already tangent to either to two lines or two circles. We said that for like example A, example B, in case that you have a curve like this one with a radius of 20 that is already tangent to two lines as given here, and there is an angle between them of 45 degrees. Here also this curve is a tangent to two lines. This curve is a tangent to two lines, and there are different angles between these three cases. So we have A, B, C. These are the three cases that would have a curve that is tangent to two lines. So we're gonna know how we can draw this one. Also, the other case here, like D and E, we do have these two curves with a radius of 40 and radius of 300. Both are tangent to two circles. Here, these two curves with radius 100 and the other one with radius also was 100. Both are tangent to two curves, two circles. So we're gonna know how we can draw these curves. Here, this is the mixed case that you have the curve is tangent to a line from one side and it is tangent to a circle from the other side. So let us know these, because these are all of these cases cover all the cases that you would have or experience for a curve that is tangent to either two lines, two circles. So let us know how we can draw these curves or tangencies by hand. So the tool that we needed, as we discussed in the class, definitely since we can use, that is fine to use the Aristo triangle, since we are not planning to have the T-rollers in addition to the drawing board. So we can use the Aristo. Aristo include lots of lines that we can use for the parallel and the perpendicular lines, that mean that to have consistent drawings, and the line that we're already drawing are consistent together. And it would require, I mean, like using Aristo, it would require some practice from your side, but it is easy. We can hack this one, and even with some practice you can use it simply. Another thing that included here in Aristo, as you can see, that there is Protractor that is already embedded and built into the triangle. And it is not just the Protractor here, it is already defined by starting from 0, 10, 20, 30, 40 up to the 180 degree. This is the 90 degree and this is the 180 degree. And also the degrees are already located over the sides, these two sides of the triangle. And like here, for example, this is the 10 degree, this is the 20, this is the 30 degree, 40, and this is the 90 here up to the 180. Or if you're moving from this side, this is gonna be the 10, the 20, which is the 20, you're gonna see like two numbers here, one is 20, the second one is 160. Here you're gonna see also two numbers, 160 and the 20. And as you can see, the triangle itself, it is 45 degree in general, like it means that this angle is 45 degrees, this one is 90 degree, but this one also is 45 degree. Make sense? So so this is one of the tools that we need. Definitely you're gonna need razors just to remove anything or edit over any line that you're gonna draw. In addition, as we discussed in the class, we need some pencil sets. A pencil set, and this pencil should include lots of pencil, but with the aid of the AutoCAD things and this software, we can it won't gonna be hard for us to have multiple sizes of the pencil, but we agreed to have two pencils are enough for this class. One is the 0.5 and the second one with the 0.7. As of myself, I prefer, it's up to you, you can change and you can do like what I've did here. I prefer using like thicker pencils, so that's why I've brought here the 0.7 and the 1 millimeter pencil. I'm gonna use this one for finishing the drawing, but the 0.7 I'm gonna use it for the mainly out just to create the drawing. Then once I finish everything, I'm just gonna use the 1 millimeter as I'm gonna show you to finish the drawing. In addition to these two pencils, the lead set itself, I'm using for B for the 1 millimeter. B, it gives the lead, it will be very clear and it will be easily drawn and it is kind of soft. But the hard one, it is preferred for the main pencil that you're gonna use as base drawing at the beginning. But the pencil that you're gonna use for the finishing, it is preferred to have like B or even HB is quite enough. So what I did here basically, because I couldn't able to find H for the 0.5 from the store that I was bringing these things. So I found here HB for the 0.7 and B for the 1 millimeter. Mean that the B is too soft. HB, this is the intermediate lead grade, that it is intermediate thing between hard and soft. So I decided to use the 0.7 HB for this one, and the this lead set for the 1 millimeter to be B. I'm gonna use this one for finishing, but I'm gonna use this one for the main drawing in the beginning. In addition, definitely in addition to these pencil sets, I do have the canvas that we're gonna use it for drawing the curves and the circle, and definitely we're gonna use it a lot here since we're already talking about circles and curves and these aspects. Make sense? So here we go, how it starts. Let us start with this very simple example that you have two lines. As definitely given here, the length of these two lines are not given, but our main interest is just to draw the curve that is tangent to these two lines following the engineering drawing. So as we explained previously, that in case that you'd have a curve that is tangent to a line, you have to draw another line that is parallel to the original line and with a normal distance between both of them equal to the radius of the curve. The radius of the curve here is 20, so I'm gonna draw in the beginning these two lines, then I'm gonna draw one line here, and there is another line here that both parallel to the baselines or the original lines, but with a normal distance is 20, which is equal to the radius of the curve. Their intersection of these two lines, this definitely gonna give us the center point of the curve, then we can draw the curve as we explained. So I'm gonna start with the 0.7 pencil here, and this is my drawing sheet, and I'm gonna consider this example A in the corner as already, like I'm gonna try to have it like very similar to what is given here. So in the beginning I'm gonna draw these two lines here. I'm gonna draw two main lines in the middle just to be like a reference to me to achieve some consistency in the drawing. So I'm gonna align one of these big lines, long lines, black lines of the Aristo triangle to the edges of this paper sheet. So like I'm going to align this line here to the edge as shown here. Then I'm just gonna draw a very light line that is barely seen. See, I'm handling the pencil very smoothly and moving over the paper. So I've drawn a line that is, I'm pretty sure that you won't gonna see this line except me, because it won't gonna, you cannot see this one through the video, but I'm pretty sure there is a line here and I see this line, but it is very light line because it is not included in the drawing. It's just a baseline that I'm gonna use for the parallelism and the perpendicularism that I'm gonna use through this video or this drawing. Then I'm gonna align this big line over the line that I just drew, the horizontal one, and I'm gonna draw another vertical line that is also barely seen in this way. So you could consider that these are two main reference lines that we're gonna use for any vertical line. It should be parallel to this line, and any horizontal line should be parallel to this line. Anyway, let us start with example A that is already given there. So I'm just gonna draw two lines. One is a horizontal line, so I'm gonna align this line to the horizontal line the baseline that I just drew the horizontal one, just to make sure that I'm gonna have here a very horizontal line. So I'm just gonna draw a line that it should be very light in the beginning, but I'm just gonna increase the thickness, or I'm gonna push hard a little bit so it's gonna be seen in the video. But it is not necessary in the beginning to have this one is a thick line or clearly seen. It is advised to smoothly draw in the beginning everything. So this is the first line. Then I'm gonna have here the second line. So I'm going to align this horizontal line because I need it vertical, right? So this horizontal line is going to be aligned to this horizontal baseline that I draw in the beginning, and then from here, from this point, I'm just gonna drop vertical line, which should be very light line in the beginning in this way. Even you can turn and just give a little bit clear, make it clear somehow so you can see what I'm doing. So this is the angle, these are the two lines, and I should set up here a curve that is tangent to both of them. So we said that to draw the curve, we have to draw two other lines that parallel to the baselines, but the normal distance should be 20. So the 20 millimeter distance here, the radius, we got it 20 because of the radius of the curve is already 20. So what I'm gonna do, I'm just gonna measure over this vertical line 20 millimeter distance, which is gonna be like 1 centimeter, and there is another 1 centimeter. This gives in total 2 centimeters. Then I'm gonna mark a point, very small point, and then from this point I'm gonna try to align one of these lines of the triangle Aristo to the horizontal line. Then I'm gonna draw the very light line that is barely seen. This very light line, this is a locus, one of locus to the center point of the curve, to the center of the curve. It means that the center of the curve should be located somewhere over this line, but where exactly we have no clue. We're gonna get it exactly by another locus, which should be the parallel to the other line. So I'm gonna measure over the horizontal line 20 millimeter as well in this way. So this is gonna be 10, 20. Then I'm gonna mark a point. Then from this little bit small point, I'm gonna draw a line that should be also as well completely vertical. So as you can see, I drew two lines. These two lines, they're gonna intersect at a point. This point of intersection, this should be the center point. Here, this should be the center point that I'm talking about. Then I'm gonna use simply the canvas and fix with the metal tip here at this center point that you just located. Then you just gonna touch at any one of these 2 points that you mark in the beginning here, either this one or this one. And if your dimensions are accurate and your measurements are accurate and try to draw the curve, it will be completely tangent. As you can see, the curve, it is completely tangent here and it is completely tangent from the other side. Make sure, it is advised to have make sure, try to rotate and skip this point. If you try to rotate and skip this point as shown here, you're gonna see that it is completely tangent. It is not intersect, it doesn't intersect with the line, the same thing from this side. So this indicates that my measurements were highly accurate. If you made your measurements accurate and make sure that these lines are completely parallel together, and you're gonna get the correct position of the center point, and definitely when you try to draw the curve, it will be definitely tangent to the two lines, and you won't gonna face any problems with the tangencies. Make sense? So this is for example A, which is very simple. Now I won't gonna finish the drawing. I'm just gonna finish the drawing by this 1mm pencil, but at the end of once I finish everything. So this is for part A, for example A. I'm gonna move right now to example B, and I'm gonna try to be fast somehow. So I do have another line that should be horizontal. There is another line that should be inclined with an angle 45 degrees. So I'm gonna draw a horizontal line, then the 45-degree line. So I'm just gonna make use of the previous line that I drew, then I'm just gonna extend it to be have a good shape of the overall drawing. So I'm gonna extend this line here a little bit, then I'm gonna have from any point like this point, I'm just gonna draw from any point here, I'm just gonna align this black line over this horizontal line, then I'm just gonna draw a line. This line, the angle here between these two lines, definitely it is 45 degree because the triangle that I used was the 45 degree. It means that this angle is already 45 degrees. So I set up here over a line, then I draw a line. So definitely this line over the horizontal axis will be 45 degree. Then I have to draw two other lines. One is parallel to the first line, the second one is parallel to the second line. But the normal distance should be the radius. The radius here of this curve is already given by 20. So what I'm gonna do, I'm just gonna measure normal to this line. So I'm just gonna increase the thickness of this line a little bit so you can see, it's gonna be seen in the video. And this is the second line, which is already given here, right? So what I'm gonna do, I'm just gonna add here, draw a very light line, vertical line that is barely seen. Then over this line, I'm going to measure 20 millimeter, 10 and 20. So this is the mark. Then from this point, I'm just gonna draw a line that is completely parallel to the previous line in this way. So this is the first line, this line here, this line, this is the one that is parallel to the baseline or the original line. Then I'm gonna do the same but for this line that is inclined with 45 degree. So I have to measure 20 millimeter normal, perpendicular, it should be perpendicular. So I have to draw a line first that is perpendicular. This is the line that is considered to the black line of the triangle itself. Both are considered. Then you're gonna draw a very light line. Then you're gonna measure 10 and 20. Mark a point. Then from this point, you're just gonna draw a line that is parallel to the original line, and the normal distance definitely is gonna be the 20 that we just measured. So now we got this line, and we got another line, which is this one. These two lines, as you can see, this line and this line both are locus to the center point, so they're gonna intersect at a point. This point definitely is gonna be the center point of the curve. Then again, use the compass, just fix at this point, which with the metal tip. Then you just start to touch somewhere, but basically you have to open. It is advised to measure 20 millimeter over the triangle to have this opening as 20 millimeter. Then you're gonna draw the curve. Or even if you try to give a touch to the first line and touch to the second line, this is gonna give us the tangency. As you can see, I do have a little bit shift here, right? There is a little, very small intersection that already shown here. It means that my measurements were not 100% accurate. It means, but it is acceptable. It means that even in the finish, I can get rid of this problem. So I do have here, it touches perfect from this side, but it has something here from the other side. But anyway, it is somehow acceptable. All right. So this is for the second curve, and again, I won't gonna finish anything now. Then I'm gonna move to till I finish the others. Now let us move to the third curve here, which is this one. It has a horizontal line, and this angle is 120 degrees. So what I'm gonna do, I'm just gonna use the same line here, tracking over the same line. Then I'm gonna draw a very light line that is barely seen. Then from any point, like for example, from this point, I'm just gonna measure 120 degrees. So if you measure 120 degrees from this point, and so we're gonna have all of this is 90, then we would have 100, 110, and 120. So this is gonna give us a point which it should be somewhere outside the paper limit, right? So, but try to fix the paper, and then you're gonna give, you know, like draw a line. I missed the point. Yeah, I see the point on the disk. I moved the paper. So repeat the measurement again. Okay, it's gonna be like 120. So this is gonna be the point here, and just keep eye over this point, and then connect this point here to the center point that you just located. Right, so we got this angle. So this should be the second line. So I do have here one line, which is this one, and there is another line which it should be this line. All right, then I have to set up a curve between them that is tangent to both. So I have to draw a line, two lines. One is parallel to the horizontal line, one is parallel to the vertical line, to the inclined line. The one that is parallel to the vertical line, no problem, it is easy. We can easily draw this one. If you just draw a very light line normal, then measure 20 millimeters and mark a point, then from this point you can easily draw a line that is horizontal to be parallel to the first horizontal line. Then we have to do the same. So we have to measure from any point, draw a line, very light line that is perpendicular to this line. Then measure over this very light line 10 millimeter and 10 millimeter, 20 millimeter, and mark a point. Why 20? Because the radius of the curve is already 20. And mark a point. Then from this point, you're gonna draw a line that is completely parallel to the baseline or the original line. And this is the benefit of the arrosto in this case, that you can easily find these parallelism or parallel lines simply. Then the intersection of these two lines, this is going to give us the center point. Then from this center point, you're going to open the canvas with the 20 millimeter. Then you're going to fix in this center point and try to draw a curve. As you can see, the curve touches from this point, from this line perfectly, and as well it touches the second line or the other line perfectly. So it means that our measurements were accurate. So I've finished the first three lines or the three examples. Now I can move to the circles, do the same. Then at the end, I'm gonna finish the join. Let us start with example D here. That we have two circles, so we have to draw the two circles first. And you should keep in mind, to draw the circle, we have to look at the center point of each one. So let us start, if we decided to start by drawing the small circle. So we're gonna pick any point to be the center point of this circle. Then we're gonna draw a horizontal line and measure 85 millimeter to locate the second center point. Then we just definitely gonna draw the two circles. The diameter of the first one is 40, the diameter of the second one is 80. Then we can work on the tangencies here of the other two curves. So it means that, and this is basically what we did for the lines. We draw the line first, then the last thing, we draw the curve that is tangent to the two lines. So we're gonna do the same for the circle. We have to draw the circle first, and then we're gonna draw the curves that already using the tangencies concept. So let us draw the circle. The first circle we're gonna pick, it is with a radius of 20 because the diameter is 40, and we're gonna pick any point to be its center point. So I'm just gonna pick here. Let us draw a second row here. Okay, let us, yeah, this one is enough. And I'm gonna draw this very long horizontal line to be like the second row, and over this point I'm gonna choose this is like the center point of the first circle, and it has a radius of 20. So I'm just gonna open the canvas with the 20 millimeter. Just measure 20. Yes, it is already opened by the 20. Then I'm gonna fix in the metal tip here and just simply draw the first circle. So this is for the first circle, it is easy. Then over the same center line, I'm just gonna measure from this point over the horizontal line 85 millimeters. So this is gonna give us 85, which is it's gonna be this point, and then mark a point. This point is gonna give us the center of the second circle, and the diameter of the second circle is already given by 80. It means that the radius it should be 40. So I'm gonna open the canvas twice, or double the diameter, so it should be like 40 millimeters opened. And from this point, from this center point, I'm just gonna draw the second circle. So this is gonna give us like another big circle as given here. Make sense? Now we have to work over the tangencies here. We do have, let us start with the small curve, which is the R40. As we practiced before, as I explained, you just ask yourself, simply, we have to locate the center point of this curve. So you have to ask yourself where it should be the center point of this curve. It should be located somewhere here. Then, this is the first question that you're gonna ask. Then the second question is, how long is the distance from the center that we doesn't know yet to the center of this circle? It's gonna be the 40 plus the 40. It means that it's gonna be the sum of the radius of the first curve plus the sum of the radius of the second curve. So it means that I have to open the canvas from and fix from this center of this circle by 40, the radius of this big circle, plus the radius of the curve itself, which is gonna be 40 plus 40 gives 80. And then I'm gonna draw an arc. This is gonna be the first locus. The same, if you ask yourself, how much is the distance between the center point to the center of the small circle? You're gonna realize that it should be the sum of the radius of the curve plus the radius of the small circle. So it's gonna be the sum of the radius, very simple. So it means that it's gonna be 20 plus the 40, this is gonna give us 60. So from this center, I'm gonna open the canvas with the 80, and from this center, I'm gonna open the canvas with the 60 to end up with the center point, and this is what I'm gonna do. So first of all, open the canvas with the 80 millimeter. From this point, I'm gonna open with the 80 millimeter this way. Then I'm gonna fix in this point and draw a big arc. Doesn't matter that it intersects with the other joint, because all of these are just locus line that we're using to assist us to locate the center points of the curves, but no problem. Then from the other small circle, I'm gonna open with the 60. So it's gonna be 60 in this way. Then I'm gonna fix here and draw another curve. So these two curves, they're gonna intersect together at a point. This point definitely is gonna be the center point of the small curve. Then this curve, it has a radius of 40. So what does it mean? It means that I'm just gonna fix here. I'm gonna open with 40 millimeter. Then from this center point, I'm just gonna draw a line. This a curve. This curve, if your measurements are accurate, it should be definitely tangent, as it is just acceptable for my case, right? If we did the same, we can repeat the same for the 300, as I'm gonna explain to you. So for the 300, it's gonna be very similar. You're just gonna ask yourself the same questions. Where is here? We are working over the 300 radius, right? So if I ask you where it should be the center of the R300 radius of this curve, it should be up or down, it should be above, on the top, or blue, it should be on the top here, above here, at this point, like this point. Then, so this is the first question. that you have to locate, or the first step, just virtually locate the center of this curve. Then you're just gonna ask yourself, how much is the distance between the center of this curve to the center of this curve? This distance, for example, if I ask you how long is this distance from the tangent point to this center, it should be, all of this distance is 300. So if we subtracted the radius, of this big circle, this is gonna give us the distance, which should be 300 negative 40. Make sense? Simply, you're gonna find a very easy way to define how much of the radius. As we explained in the video, in the slides, it should be either the sum or the difference between the two radius, right? The two radius. So in this case, it's gonna be the difference between the two radius, the 300 negative the 40. Why is it the negative, not the addition, or the subtraction, not the addition? Simply, if I ask you to move from the center of the curve to the center of this circle, are we gonna go over the tangent point? Because this is the curve and these 2 points are the tangent points, right? So if you try to move from this center to the center of the big circle, we will not go over the tangent point, so we have to subtract. Very simple. So if we're gonna go over the tangent point while moving from the center to the center, we're gonna add, it should be addition. If we will not move over the tangent point while moving from the center to the center, this should be subtraction. Very simple. The same thing from the other side. The other side here, if you try to move from the center of this curve to the center of the small circle, we will not move over the tangent point. The tangent point is blue, is far from the path from the center to the center. So what does it mean? It means that we have to subtract. So what we're gonna do to locate the center point, we have to fix at this center of the big circle and open the canvas by the difference between the two radii, which is 300 negative 40, which gonna give us the 260, right? Then you're gonna fix here and draw a curve. Then what? You're gonna open the canvas one more time, but from this side you're gonna open the canvas by the difference between the 300 and the 40. So 300 negative 300 negative 20, because we're gonna subtract 20. This is gonna give us 280. Then you're gonna draw another curve. The intersection of these two curves should give us the center point of the curve. Then we're gonna open the canvas by the 300. This is gonna give, then we can draw the curve that it will be definitely tangent to both of them. Make sense? But if we try, I don't believe that the canvas that we have can be opened by 300 millimeter, because 300 millimeter, it should be like almost that width, right? Because this one is exactly 300 millimeter. So it is huge. It means that my canvas is too small to be opened by the 300. So I'm gonna do some changes to this exercise here, so you can even work on it at home. So let us assume that this radius is just 100 millimeter. Instead of being like 300 millimeter, assume that it is 100 millimeter. So what does it mean? It means that I'm gonna fix from this point, open the canvas by 100 negative 40, which is 60, and draw a curve. Then from this center, I'm gonna fix with 100 negative 20, which is 80, to end up with the center point, and this is what I'm gonna do. So from this point, from this big circle, I'm gonna fix and open with the canvas by the 100 negative 40, which should give us 60. Then this, from this center, I'm gonna draw a curve. This curve should be locus to the first center point, or the first locus of the center point. Then from this small circle, I'm gonna open the canvas by the 80, which is 100 negative 20. So it should be a little bit bigger in this case, and this is gonna give us the second locus. So this should be the center point that I'm talking about of the big radius. So if you open the canvas now with the 100 millimeter, which is 10 centimeter, and fix from this point and draw a curve, if your measurements are accurate, as typically I'm getting here, it is perfectly tangent from this side and it is almost tangent from the other side. It means that there is a small gap here. It means that I have something not accurate in the measurement in either the radius of or the radius that I opened, or the opening of the canvas from this center to this center, or it means that the 60 or the 80 or even the 100 that I'm drawing with, right? But we can fix this gap while we are doing the finish of the drawing. Make sense? So that's it for this example. So now for this example here, we do have this big circle and there is a small circle here with diameter 40, and this circle is already with diameter 80. But the 100 that already given here, if you try, you would find some trouble or problem to draw these curves with the 100 and the 80, because you had to open the canvas with 180 and the 180 would not be enough for us to I mean that the canvas would not be able to open by the 180 distance. So we can scale down the dimensions, like we're gonna divide all the dimensions over 2. This is scaling down to like multiplying or doing scaling by half. It means that we're already dividing all the dimensions by 2. So this 40 should be like 20, and this 100 is gonna be like 50, and this 100 is gonna be 50, and this 100 is gonna be 50, and this one is gonna be 40. Just scale down all the dimensions so you could able to use the canvas, and this is what I'm gonna do. So I've tried before to draw the circle, big circle here. Let me check if this distance is gonna be 50. Yeah. So I've drawn the big circle with a diameter, 40. It means that the radius that I used was 20, and this gives us the big circle. Then here next to it, I'm gonna draw the small circle, which is already had a diameter after the scaling. The diameter became 20. It means that I'm gonna open the canvas with 10 to draw the other one, but the distance between them, it should be 50. So I'm just gonna draw a line here, a horizontal line from this point and measure 50. This is gonna give us the center of the second circle, the other circle, in this way. Then I'm just gonna open the canvas with the 10 millimeter, and I'm gonna try to draw this little small circle in this way. Alright, then your objective that is to work on these curves. Let us start with this first curve, which is radius 50. These two tangent curves are both having the same radius. So the radius 50 of this curve, if I ask you where it should be the center point, it should be somewhere above here, right? Then if I ask you to move from the center to the center of the small circle, are you gonna go over the tangent point of this curve to the small circle? No. Why? Because the tangent point of this circle, of this curve to the small circle, is down here. And we will not go over the tangent point, we will not pass over this tangent point. It means that we have to subtract. We are going to subtract 50 negative 10, because the radius of this small circle is just 10. So it's gonna be 50 negative 10, this gives 40. So I'm just gonna open the canvas by 40 and draw a curve. This curve is gonna give us the first locus to the center point of the small circle. Then I'm gonna do the same for the second big circle. If I ask you to move from the center of this curve to the center of the big circle, are we gonna go over the tangent point? Yes, we're gonna go over the tangent point. Why? Because the tangent point is this one. This is the tangent point of the curve to the big circle. We are working over this curve. So if we try to move from the center of the curve, that we don't know exactly where it is, but we assume that it should be here. It is not assumed. It should be somewhere in this region. So moving from this center to the center of the big circle, we're gonna go over the touch point. It means that we have to sum the two radius. So it's gonna have 40, the radius here, it became 20 plus the 50, which after the scaling, so the sum is going to give us 70. So it means that I'm going to sum 20 plus 70 plus 50, which gives us the 70 radius. Then I'm going to fix from this center point and draw a curve. So I do have one locus here, and there is another locus. Both they're going to intersect at the point. This point, it should be the center point that I'm going to use to draw the first curve with a radius of 50. So I'm just going to draw the first curve with a radius of 50. Fix from this center point this way and draw the curve. If your measurements are accurate, you're going to find that the tangency will be perfect as I got it here. Repeat again for the other curve. The other curve, it should be somewhere. The other curve is oriented this direction. It means that its center point, it should be somewhere here, right? So, and if you try to move from this center point to the center of the big circle, we will not touch, we will not go over the tangent point, because the tangent point of the curve to the big circle will be down here. It means that from the big circle we're going to subtract how much? We are going to subtract the difference between 50 and the 20, because the radius of this circle became 20. So 50 negative 20 gives 30. So I'm going to open with 30 from this big circle, from the center of the big circle, while from the other center, the center point, it should be here. So if I ask you to move from this point to the center point of the other small circle, we're gonna go over the tangent point, because we are working over this curve. Since we're gonna go over the tangent point here, we have to sum the radius. This radius will be summed to this one. So the sum of the two radii gives us 50 plus 10, because the radius of the small circle is already 10. This gives us in total 60 millimeters. So we're gonna open 60 from the small circle, but 30 from the big circle. And this is what we're gonna do. So I'm gonna open with the 60 from the small circle, 60 millimeters, then fix in the center of the small circle, draw a curve. Then there is another curve with a radius of just 30, but from the center of the big circle, it's gonna be in this way. The intersection of these two loci gives us the center of the curve with a radius of 50. So I'm gonna open the radius of the curve is already given by 50. So I'm gonna open comes with the 50 to draw this radius. If your measurements are accurate, you're gonna end up with a perfect tangency between the two circles. So as you can see that I got it perfect to this circle, but the small circle, there is something wrong. It means that I have to double check again the curve that I draw from the center, which it should be 60. So if you try to repeat the 60 one more time here, we are getting the same. So it seems that there should be some shift, a little bit shift in the center point, which is just acceptable, right? So this is for this example, which is example E. Now I'm gonna move to the last example here for the case that we do have a circle and line, and the curve is tangent to both a line and a circle. So for this example, I'm gonna use the back because I don't have any space here. So in the beginning, I'm just gonna draw the line and the circle, and the diameter of the circle is already given by 80. It means that it has a radius of 40, and the line, it should be at a distance of 65 from the center point in the horizontal dimension. Then you can look at a point and draw a vertical line. So, and this is what I'm gonna do. So in the beginning, I'm just gonna open the cams by the 40 millimeter radius. Then from any point, I'm just gonna draw this circle. This should be the big circle, no problem. Then from this center point, I'm gonna draw a line. That is, I'm just gonna make sure that it is parallel to the edges of the drawing sheet. That is horizontal in this direction. Then over this line, I'm gonna measure a distance of 65. Distance of 65, and mark a point. Then from this point, I'm just gonna draw a line that is vertical in this way. Make sense? So I got this line, which I'm just gonna make it clear somehow, just to see what I'm doing. Alright, the objective now is just to draw a curve that is tangent to these two objects, like this circle in addition to this line. For the line, I have to draw a line that is exactly parallel to this line, but with a normal distance between them is 40, which is exactly the same radius as this curve. So what I'm gonna do, I'm just gonna measure over this horizontal line 40 millimeter distance, and then I'm gonna mark a point. 40 millimeter is gonna be this point. Then I'm just gonna draw a line that is completely parallel, that it should be parallel to this vertical line, right? Even if you try to double check and give it rotation here, it should be completely parallel to this vertical line. So this is one first locus of the center point of the curve. How about the second locus that we're gonna use the other object that this curve is already tangent to? It tangent to this circle. So from the center of this circle to the center of the curve, the center of this curve, it should be somewhere in this region, right? And this should be the tangent point. So if I ask you to move from the center to the center, are we gonna go over the tangent point? Yes, we're gonna go over the tangent point. It means that we have to sum. We're gonna sum the 40 plus the 40. This first 40 is the radius of the big circle plus the 40, which is the radius of the curve itself. It means that we have to open the comes by 80, and then we're gonna end up with another curve that defines the second locus of the curve. From this center, we're gonna draw a curve. This is gonna give us the second locus. The intersection of these two loci at this point, this is gonna give us the center point. Then we're gonna open the comes with the radius of the curve, which is already given by 40, to draw the curve. So from this point, I'm just gonna fix here, draw a curve. It's gonna be, make sure that it is already over the center point. It's gonna be tangent to the first circle and as well tangent to the line. As you can see, there is some intersection, but it is just acceptable for like this, especially this side, but it's just acceptable for the other side. But anyway, we can manage this one with the finish that we're gonna do once we the finishing of this drawing. All right. So I've created and generated all of these tangencies here, and as you can see, there are lots of lines, and even if you're gonna look at it, you aren't gonna able to distinguish between the baseline or the other lines and curves that are used to assist me to locate the center points of these curves. So it means that we have to do finishing over this drawing, that we have to go over again these circles and these lines to make them clear using the 1 millimeter pencil, and this is what I'm gonna do. All right. All right, so I've finished the drawing. I've done. This is how it's gonna look like after the finish. It's gonna be much more clear and net. And as for this extra line, that is fine to keep them. So that's why in the beginning I said that it is better to use the 0.5 or the 0.7 HB or H pencil. So these lines, in this case, this line should be very light. But as you can see, these lines already seen. You can see them in the video. But I've pushed hard while I was drawing this line just to make so you can see them in the video itself. But while you're already working, you shouldn't draw these lines to be clear. It means that these lines, extra lines, because they are not existent in the drawing, so do your best to make them very light or barely seen, so you won't gonna spend time in erasing them or removing them from the drawing. But that is fine even if you just leave them, but they should be very, very, very light. It means that at least there should be a contrast between the exact curves and line that we need of the drawing and these extra lines. It should be very light, as I mentioned, and this is the other example. Now what I'm gonna do, I'm just gonna move to the another example that we do have a drawing, and which is this one, and we're gonna see how we can create this drawing using by tangencies. All right. Now let us consider this example here, that this drawing is a two-dimensional sketch that includes lots of tangencies, and we would like to repeat this one manually, typically the same. We're just gonna stick to the dimensions, but we will not add the dimensions to the drawing. Make sense? So how it works, the first thing that you have to locate the curves that are tangent, that the tangencies basically. And if we decided to locate these curves, it's going to be one curve is with radius 25 and this big curve with 112 millimeter radius. Also we have this curve and we have another curve, and there is the 16 curve, which is already this one. So in total we do have how many tangencies? 1, 2, 3, 4, 5 curves that should be tangent curves to other objects, circles or whatever, right? So in order to create this drawing, these curves, it is advised to keep them at the end. That the last thing that you're gonna do is just these curves. So what I'm gonna do, I'm just gonna draw all the other things that I already have dimensions for, like these two circles. I can draw these two circles, I can draw this big circle, the same thing what's inside here. Also there are two other tangencies, which are these two small circles, curves here already tangent to these two big small circles. So it means that I'm just gonna start with the thing that I do have data for, then I'm just gonna work on the tangencies later. Make sense? So in the beginning I'm just gonna draw this big circle, and this big circle, it has a diameter or a radius. It has a diameter of phi 80. Phi 80 is already defined for this big circle. It means that it has a radius of 40. So in the beginning, from a center point, and it is advised in case that you have a drawing sheet to work in the portrait style. It means that in the vertical direction, so it would be enough for you to have the drawing depending on the scale. So align the drawing or the drawing sheet to be vertical, and as usual, just draw one vertical line that make sure that it is concealing to the edge of the drawing sheet, and draw a very light line to be vertical. And I'm gonna draw another horizontal line that is perpendicular to this one as two main reference line, right? Then I'm just gonna start from any point to be like the center point of this big circle as just a start. You can even consider the center of this circle at the of this circle to be the start, or this center or this center, it's up to you. But since this is the big circle, it is better to have this one at the start one, right? So let me assume that this point in the middle here is gonna be the center point of this big circle. And again, the diameter of this circle is 80. It means that it should have a radius of 40. So I'm gonna open the canvas with the 40 millimeter. Then from this center point, simply I'm just gonna draw a circle, big circle in this way. Make sense? Then inside this big circle, there are two small circles over apart by 46 distance, and their centers are located over the center line, the horizontal center line of this big circle. It means that you have to make sure that you do have this horizontal line of the circle is already located, which is this one. Over this one, I'm just gonna measure 46 over 2, which gives us the 20 plus 3 is gonna be 23. So I'm just gonna measure 23 from the right and mark a point. This should be the center of the right circle, and another 23 from the left. 1, 2, 3 is gonna be this one. So I got the two centers. Then the radius of each one of these centers, it should be 13 because it has a diameter of 26. So the diameter of 26, it means that it should have 13 as radius. So open the canvas with the 13 millimeter. Then simply from this center, you're gonna draw a circle, which should give us the first circle here. It shouldn't be accurate for now, but anyway, you're just gonna finish everything at the end. So this is gonna be the second circle. Then there should be in the middle two curves here. If you would like to draw these two curves at the moment now, do it. If you can feel that you're gonna skip or forgot these two curves, or if you would like to keep them at the end, it's up to you. So let us do these two curves now, because they are two very simple curves. The key idea here, because we do have lots of curves in this case, it is different than the previous example, because in the previous example we already have two objects and we do have a curve between them. But we do have lots of curves and circles, so you have to make sure what are the things or the objects that the curve already tangent to. Like for example, this curve is already tangent to these two circles. So I'm gonna use their centers to locate the center of this curve. Make sense? Where is the center point of this curve? We have no clue. This curve, it has a radius of 24. This is the only information that we have about this curve. But where is its center? We have no clue. So we have to specify or define this center point using the centers of the two objects that the center of the two circles that this curve is tangent to. This curve tangent to this circle and this circle, so I'm going to use these two centers here. But where it should be the center point of this curve, it should be somewhere above here, right? And if I ask you to move from this center to the center of this curve, are we going to go over the tangent point? Yes, we're going to go over the tangent point, which is this one. It means that we have to add the radii. It means that we're going to have 13, which is the radius of this curve at circle, plus the 24, which gives 73 in total, right? Then 73 in total. Then I'm going to add here the same. If you try to move from the center of this curve to the center of this circle, we're going to go over the tangent point. So what does it mean this? It means that we're going to add as well 13 plus 24. So in total it gives 37 as well. So it means that from the two centers, I should open the canvas by the 37. So I'm going to open by 37 millimeter. Then I'm going to draw a curve from this center and another curve from this center. If your drawing is accurate, these two curves should be intersecting together at over the vertical line that over the center point of the big circle. Why? Because you are opening with 27, with 37 and 37 from the right and the left. So definitely this center point, it should be located in the middle between these two centers. And this is what we got here. It is typically considered over the vertical line. This should be the center of this big circle, of the curve. Then you're going to open the canvas with the 24, which should be the radius of the curve. Then you're going to fix from this point and start to draw the curve. If your drawing is accurate, you're going to end up with a perfect tangent as I already got here. How about the other curve? The other curve is identical to the previous one, right? So what does it mean? It means that definitely the center of the other curve, it should be somewhere down here, right? And it should as well over this vertical line. And since it is identical, I'm gonna, even if you try to move from this center to this center, we're gonna go over the tangent point. It means that we are going to sum the radius, means that it's gonna be 13 plus the 24. So we're gonna open the canvas again by this 37. So if you open the canvas by the 37, from the center of this circle, you can even get the 37 from here and mark one point here, the same, or one locus, one curve here. They both gonna intersect. It should be intersecting over the vertical line. Then you're gonna open the canvas with the 27, with the 24, I'm sorry, which is the radius of the curve. We're gonna end up with a perfect tangent or tangency in this case. So we already drew the thing that in the middle, very quick. I didn't finish anything. Skip this line, these lines known as the hatching lines. I'm gonna show you how we can draw this hatching line. But anyway, this hatching, we're gonna use it a lot for, especially for the sections, to indicate sections. This is one of the topics that we are going to cover at the end of the semester for the engineering drawing. Then we're gonna move to these two circles. We won't gonna able to draw this curve. Why? Because this curve is tangent to this big curve. The curve, which is 52, is tangent to this big curve, and we already have this big circle. Also, it is tangent to this circle with the external one with a diameter of 36. But we don't have this circle yet, so we have to draw it first. So that's why I'm gonna draw these two circles first. To draw this circle, I have to locate the center point. So this center point, I have this center point of the big circle here. So if I ask you to move from this point to this point, what you should do, you're gonna move up a distance, then you're gonna move right? So if you're gonna go up this vertical distance, which is 65, then you're gonna move right with 55, you're gonna end up with the center point. And this is typically what I'm gonna do. I'm just gonna measure on the vertical direction 56 distance, as already given here. I'm just gonna measure 56 distance. Let me put this one down. So just measure 56 over the vertical line. Then from this point, I'm just gonna draw a very light line that is gonna be locus to the center that I'm seeking, which is the center of the two circles. Just very light line. Over this line, measure 55 millimeter, and mark a point. This is gonna give us the center of these two circles. Then I'm just gonna draw the two circles. The first circle is the base one. It has a diameter of 36, so the radius, it should be 15 plus 3, 18. It should be 18. So I'm just gonna open the canvas by 18. Then I'm just gonna draw the first big circle, which is this one. Make sense? So this is the big circle here. How about the second circle, the small one, which basically just a circle, it has no tangencies with, but it is a circle with a diameter of 18. It means that the radius should be 9. So the radius, it should be 9 in this case. This should be the small circle. Alright, so I got these two circles. There are some curves. Skip these curves on the top here and let us work on the other circle down here. Then we're gonna finish all the circles, all of them together. This circle, it has a diameter. The big one has a diameter of 30, the small one with a diameter of 14. But this circle, it is already located, its center point, it is located over the center line here, this vertical center line, right? So what does it mean? And it is at 57 millimeter from this center point. So if you're standing here, I ask you to move down to the center point of this circle, of these two circles, you're gonna move down vertically over this vertical line by the 57, and this is what I'm gonna do to locate the center point. Then simply you can draw the two circles. So if we did it from this center point, I'm just gonna measure 75 millimeter. This should be the center of these two circles. Then the big circle, it has a radius of 15 because it has a diameter of 30. So the radius is gonna be 15. Radius of 15. Then I'm going to draw this circle here. This should be the big circle. Then there is a little bit small circle in the middle with a radius of 7 because the diameter is 14. It would be hard somehow to draw these small circles, but try to do it. Okay? So we got everything except the curves, the big curve that we are seeking. Let us start with this curve here on the top. You can start with either one, it's up to you. This one, it has a radius of 52. Do you see it? And its center point, it should somehow located in this region, for example. Let us assume that it is here. Then this curve, you have to locate the tangent points of this curve. This curve is tangent to this big circle at this point, and there is tangent to this big circle here, this small circle at this point, right? So this is one tangent point, this is another tangent point. Then if I ask you to move from the center to the center of this circle, are we gonna go over the tangent point? Yes, we do. So what does it mean? It means that we have to add the radius of this circle plus the radius of the curve to end up with a locus here, right? So the radius of the curve is 52 plus the radius of this circle, which is 18. This gives in total 70, right? So it means that we're gonna fix from here and open the canvas with 70 and draw one locus. How about this center? Because it is tangent to the big circle, so I have to use its center, the center of the big circle. So if I ask you to move from the center of this curve to the center of the big circle, are we gonna go over the tangent point? Yes, we do. So what does it mean? We have to add the two already. So the radius of the big circle is already 40, plus the radius of the curve itself is 52. So the summit will be 92. So it means that from this center I'm gonna fix and open the compass with 92, and for this one I'm gonna open the compass with 70 to end up with two loci to locate the center point of this curve, and this is what I'm gonna do. So first I'm just gonna open the compass twice, one time with 70 make sure that it is perfect. Then from the center of the small circle, draw a curve with the 70. It's gonna be the first locus. Then you're gonna open with the 92. With the 92 and fix at this point, then draw another locus. So this is gonna give us the center point of this curve. Then what we're gonna do, I'm just gonna open the compass with the diameter at the radius of the curve itself, which is 52. And then fix at this point and draw the curve. If our measurements are accurate, we should get it in tangent, right? So as you can see, it is perfectly tangent here, but there is a little bit small gap here that I see. But as we said, that we can get rid of this gap while we already do finishing. But if the gap or the intersection it is significant, you have to repeat again and double check again the measurements. For example, for this case, I'm not accurate 100% because I'm still having a small gap here, right? So for example, if I'm gonna grade this one for myself, I'm gonna remove point for this one. But anyway, so this is the first one. I won't gonna repeat it. For example, if this one it will be graded, I'm gonna repeat it for myself. But anyway, so this is for the first curve. Now there are these two curves. Skip this part for now because it has something tricky. So I'm gonna skip this part. Then I'm gonna move to these two curves, finish them. It's gonna be the same procedure, typically the same. This one is very similar to this one. It is 25 millimeter and it is tangent to two objects. This big circle and this is the tangent point, and this small circle and this is the tangent point. So what does it mean? It means that it should be somewhere here. So if we try to move from the center to the center, we're gonna go over the tangent point. So we have to sum the ready. So it means that we're gonna have 40 plus the 25 in total gives 65. And from the center to the center, we're gonna move over the tangent point. So we have to sum the ready. So we're gonna have 25 plus the radius of the big circle because it is tangent to the big circle here, which is 15. So it's gonna be 15 plus 25. This gives in total 40 millimeters. So what I'm gonna do, I'm gonna open the compass twice from the from the center of the big circle and the small circle, and I'm gonna start with the 65, which should be drawn from the center of the big circle. Then I'm just gonna draw an arc. This is gonna be the first locus. Then from the center of the other circle, I'm gonna draw a curve with a radius of 40, which gonna give us this curve. So this is the second locus. Both they're gonna intersect at a point. This point it should be the center point of the curve, which is already given by a radius of 25. So fix from the metal tip here and draw a curve. This curve it should be completely tangent as I already getting it here, right? So I got this curve. How about the other curve 112? It's gonna be the same, but where it should be the location or like a tentative location of the center point of this big curve, it should be somewhere on the right here, right? So, and what are the tangent points? It has two tangent points. One point that is tangent to the big circle, so I'm going to use the center of the big circle, and there is another tangent point to the small circle here with diameter 13. Then if I ask you to move from the center to the center, are you going to go over the tangent point, this one? No. Just gonna directly move from the center to the center without passing over the tangent points. It means that we have to subtract. Subtract the 112 negative 40, which is the radius of the big circle. This gives us the 60 plus 12, which is 72. It means that we have to open from the big circle by 72. How about the small circle? The same. If you try to move from the center to the center, you will not go over the tangent point. So what does it mean? It means that we have to subtract the 112 negative the diameter the radius of the big circle here, which is 15. So it's going to be 112 negative 15. This gives us in total how much is going to be, like 98, right? Or 98 or 97, I think. I'm very bad in the calculation. Let me. It is 100 negative 15, so it's going to be 97. So it means that from this center, I'm going to open the canvas with the 97, and from this center, I'm going to open the canvas with the 72. So let us use the 72 from the big circle first. 72. And then I'm just going to draw a curve that should be locus to the first tangent point. The tangent point should be on the right. Then, as you can see, it has been moved. Alright, so just to be accurate, so this should be the curve. Right, with the same opening, here is going to be 72. Then the other side, I'm going to open the canvas with the 97. Okay, then I'm just gonna fix from the center of the small circle, and there is another curve here. So they gonna intersect together in a point. This should be the center point. Open the canvas with the 112. So it's gonna be wider a little bit, 112. This is 110 and 111, 112. Then from this center point, fix here the tip. Then directly you can draw the curve. If the measurements are accurate, you're gonna get a perfect tangency as I'm getting here. So it is perfectly tangent as already shown. Make sense? So I've finished all the curves except these two curves. These two curves are a little bit tricky because, as you can see, I do have two curves that tangent to each other. So what does it mean? It means that this curve, there is a small curve here, which is this one, with a radius of 88. Then the 16, it is tangent to this 88 radius or curve with a radius of 16. You got it? But basically, to draw a curve that is tangent, for example, if I ask you to draw the curve which is the R16, this small curve, it is tangent from this side to this big circle, and it is tangent from this side to this curve, but I don't have this curve yet. Also, if I ask you to draw this R88, it should be tangent to the R16, and from this side it should be tangent to the circle, big circle, which is the 36. Make sense? So what does it mean this? It means that there is missing information here, that this curve to be drawn, you should have the two objects drawn. So you aren't gonna able to draw the two curves. Therefore, this is because there is one missing information here in this case. This information is already given actually. If you can observe the line of this dimension, the 88, you're gonna find that this line is coincident and ends over the center line of this circle. So what does it mean? It means that this point of intersection of the line of the dimension R88 to the center line of the circle, this should give us the center of this big curve R88. Make sense? And this is what we're gonna do. So how we can locate this center point? This is the tricky part, right? So basically this curve R88, it is tangent from this circle, and it is tangent from the other side, but this other side we don't have it. So what I'm gonna do, I'm just gonna use the center of this circle that it is already there for the first tangency. From this center, I'm gonna draw an arc. This arc is gonna intersect with the center line to locate the center point of this curve R88. So again, to draw the R88, we're gonna use the center of this circle. Why the center of this circle? Because the R88 is tangent from this to this circle. So I'm gonna use its center. Then from this center, I'm gonna draw a curve. This curve, it should be with a radius R88 or the subtraction, it depends. Why? Because if this is the center of the curve R88, and you try to move to the center of the circle, why we are moving to this one? Because it is tangent to the R88 curve. If you try to move from the center to the center, are you gonna go over this tangent point of the R88? No. So what does it mean? It means that we have to subtract. we're gonna subtract R88 negative 18, which is the radius of the big circle. So this is gonna give us in total, we're gonna subtract 70. It's gonna give us 70, right? So it means that from this center point, I'm gonna open the cams with the 70 millimeter radius, then draw the curve. This curve is gonna intersect with the center line at a point. This point will be the center point of the R88 radius. And this is what I'm gonna do first, just to draw the first curve. So I'm gonna open the cams symbol by the 70. Then from this center point, I'm just gonna draw a curve with a radius 70. This curve, it should be intersecting with the center line, this horizontal center line of the circle, of the big circle. It should be intersecting with this center line here. So it's gonna intersect at a point. This point, it should be the center point. I've messed up here something. Alright, it should be the center point of this curve R88 that I'm gonna draw here. Then you're gonna open the cams with the 88. From this point, 88. Then simply you're just gonna draw a curve. This curve, it should be tangent from here, but it has no other tangent. I have no clue where it's gonna tangent. It will be tangent to the R16, but we didn't draw R16 yet, right? So you just simply just gonna draw a little bit small curve here. Then we have to draw the R16 after that. The R16 now, it is tangent to this R88 and this big circle. At these 2 points, this is the first tangent point, this is the second tangent point. Make sense? So what does it mean this? If I ask you where it should be, the center point of the R16 is going to be a little bit up here. If you try to move from the center, it is tangent to this curve, and the center of this curve, we define it here, right? So if I ask you to move from the center of this R16 to the center of the R88, are we going to go over the tangent point? Yes. It means that we have to sum the two radii. So we're going to have 16 plus 88. This gives us 90. It's going to be 16 plus 88 gives 104. So from this center point that we just located, we're going to open the cams and draw a curve with 104. This is going to give us the first locus. And this is what I'm going to do. From this center point, open with 104, 104. Then fix from this center point and draw a curve. This is going to give us the first locus of the center of the little bit small curve R16. Now we need another locus. This R16 is tangent to the big circle, so I'm going to use this tangent point here. So if I ask you to move from the center of this R16 to the center of the big circle, are you going to go over the tangent point? Yes. So we have to sum the radius. So we're going to have 16 plus the radius of the big circle, which is 40. This gives us in total 56 millimeter. So from this center, I'm going to fix with the 56 millimeter, draw a curve. This is going to give us the second locus, and this is what I'm going to do. So 56. Then simply from the center, draw a curve. This is going to give us the second locus of and the intersection is going to give us the center of the R16. Then I'm just going to open the cams with 16 millimeter to draw the curve. So fix here. This is going to give us this curve R16. If the drawing is accurate, it should be perfectly tangent here. So as you can see, it perfectly tangent to the circle, but there is something wrong with this curve, right? With the R88. It means that I have to double check again my measurements. So I'm just gonna measure. So there is something wrong with this curve, right? So this wrong thing, I have to double check this curve that it is already 88 millimeter size. Yeah, it is 88 millimeter size. Also, I have to double check the 104, which is the sum of the 16 plus 88. It should be 104 here, 104. So if I fix here and draw a curve, it typically gives me the same curve, right? Also, let us double check again this 40 plus 16, which is the 56. So 56, it should be this one. So if I draw a line here, it should give us, okay, I'm still getting the same curve, no. It's gonna be a little bit shifted here, like very small shift. Then there is R16, then R16, which is, should be this one. Then from this new center point, if you try to draw a curve from this one, I should be getting it. It tangent here, but it's going to intersect somehow with the big circle. It means that there is also some things wrong. It is not wrong, it is not accurate in the measurement that I did here. Whatever for the location of the center point or it means that a very small shift, as you can see, a very small shift here resulted in big shift in the two curves, in the two situations. Like there is a very small shift here in the center, made this big shift in the radius. It means that I have to repeat this one to make sure that it is fine. So at the end, I've finished all the curves, but I won't gonna repeat it. But anyway, I've finished all the curves shown here. The last thing that I'd like to show you how we can create or draw these hatching. This hatching, this is one of the things that we're considering not just for fun or to give a pretty shape to the or purity to the shape or the drawing, but basically we are using it for a reason, which is known as the sections, and this is the topic that we're gonna discuss at the end of the second part after the midterm for this course. Make sense? But for now, I'm just gonna show you how we can draw these hatching. These hatchings basically should be drawn by, as we discussed in the start or the first lecture, that this hatching, it should be used drawn by a light line, or we have to use like the 0.5 or 0.25 up to 0.5 millimeter pencil to draw this hatching. And it is advised to use like hard lead or at least HB. So I'm just gonna draw this hatching by the 0.7. And another thing, that this hatching will not be finished. So what does it mean? It means that, for example, as you can see, I've drawn some circles. Even this circle is not complete. This one is not complete. Why? Because anyway, at the end, I'm gonna go over the drawing to finish everything, right? So, but for the hatching, make sure while you already draw the hatching, make sure that it's gonna be the last thing that you're gonna add to the drawing just before they finish, and make sure that you won't gonna finish the hatching. You're just gonna do it once and that's it. So it means that it should be neat and clean. And another thing, that the spacings between the hatch line, it should be identical. It means that the space between this line, it should be fixed space. And another thing, that this hatching, it should be aligned all of them together in one direction and at 45 degrees according to the ISO standard of the engineering drawing. So this hatching, it is not just for fun. This hatching, it is not just to give beauty to the shape, or this hatching, it is not just we drawing any lines. No, there are some rules that we have to stick with for creating or drawing these hatching, and this is what I'm gonna do. So basically, as you can see, it is aligned in this direction. Generally, to draw a hatch, we have to start from the bottom, from either the lower right corner or the lower left corner of the area in which you are going to draw the hatch. For example, this hatch will be confined just inside the circle, so I have to start from either the right hand side, the lower right corner, or the lower left corner of a circle. But circle definitely has no corners, but it means that just from the right end or the left end of the circle, kind of, right? Since it is aligned in this direction, and since it is 45 degree, it means that we have to use 45 degree triangle like the Aristotle triangle. Then what we're gonna do, we're just gonna draw a line, then I'm just gonna jump up a little bit, draw another line, jump up and draw another line, and so on. And you have to make sure that the spacing is identical. between all of these lines. So the question is, how could I make sure that the spacing is identical? You can use these ends. Like for example, if you're gonna look to these dashes here, all the ends, the tips, the ends of these dashes, all of them are located over like a virtual line. So you can use this thing like the ends, the tips of these dashes, small dashes, as a reference for you to make sure that the spacing is the same. And this is what I'm gonna do. So I'm just gonna start here. Make sure that you have this one is aligned correctly with respect to the edges of the drawing sheet, and that's why I draw these two reference lines in the beginning before I create the drawing. So I'm just gonna use one of these lines, and from the lowest corner here of this circle, I'm aligning this vertical line to this vertical line just to make sure that the arroster is already located correctly. Then I'm just gonna have a little bit small line here as a hatching line, and remember that you're gonna use the 0.7 and make sure that you just gonna draw this line once. It means that we will not waste time again to finish or go over this line one more time, like what we're gonna do for the other circles. Then, so that's why I'm saying, what I'm saying or recommending is just leaving the hatching till the end, and you know, like you draw it once. Make sure that, for example, I do have this line is inclined to this one and or parallel to this one, and as you can see, your objective is just to observe the tips of these dashes to be considered to the line that you just draw. Let me zoom in or come close here just to show you how it works. Oops. So as you can see, what I'm doing is make sure that the tips, the ends of the small dashes already over the line that I just draw. Then you're gonna use the pencil to draw a new line, as I'm gonna do. Make sense? So I'm gonna draw the other line, then I'm gonna repeat again, and as you can see, it is just once. Then but it is clear. If you can see these lines in comparison to the other line that I drew in the beginning, it is very clear because I won't gonna repeat or waste time repeating these dashes in the finishing, as I mentioned. Then I'm gonna use the line that I just drew as a reference and make sure that it is aligned to the tips or the ends of these dashes. Then draw another line here and keep going till the end, till you finish this area. As you can see, I'm gonna skip this a little bit small dash here or line, but I'm gonna skip this region because there is no hatching in the original drawing inside these circles, right? So just I'm gonna stick to the drawing here and another. So I skipped this circle. Then, and make sure, for example, I have a difference in the contrast between this line and this line. Make sure that all of them, they should have the same contrast to be accurate in this way. Someone gonna say, why I have to be with such accuracy? Because as I said, this accuracy is very important, because remember all the time that you creating this drawing to somebody else who gonna read this drawing, not just for yourself. Because if it is for yourself, I know this drawing, I do have the drawing, I don't need to draw it again, right? But basically, in terms of engineering application and mechanical engineering, and this is what you're gonna do in the workforce after the graduation, that you draw for somebody else, for another engineer. So he gonna use your drawing for working. I know that there are software that we're already using, but as we agreed, doesn't make sense that you can use the software and you don't know how you can use your hand for creating drawing. And in many cases, the hand drawing, it is very important because it has different concepts or different techniques that should be different than the technique that you're gonna use for the computer-based drawing, right? Just carry on till you finish the hatching, which would take time till you finish this one. So by this I should be finished of the drawing. The last thing that I have to do is just to finish the hatching. Then I'm gonna finish all the drawing, go over again all of these curves, make sure that they are neat and clear. Alright, so and this is what I'm gonna do it. I'm just gonna skip the video, then I'm gonna show you at the end how it looks like when it is finished, right? So this is it for after the finishing, and I completed hatching. As you can see, there are some extra lines, these curves for the locations of the center point. That is fine just to leave them, just to show me that you already located these centers and so on. But basically, it should be like neat and accurate as already, given in this example. This one had been created by AutoCAD, but this one is just hand drawing, so it should be kind of, like identical in this way, right? So this is for this example or today's lecture. Here today we discuss the tangencies, and this is the main objective. And remember that we still stick to the two-dimension sketching. We practice how we can draw sketches for or repeat a drawing that we already have, like we already repeated this drawing typically identical, sticking to the dimensions. We didn't add the dimension yet because we didn't cover this part so far, but it will be discussed definitely how we can. I'm going to show you how we can adding the dimension and putting the dimension to the drawing. It follows standard. It is not just like that. It should be following a certain standard, and we're going to discuss this point especially over AutoCAD, because AutoCAD gives us this tool very simply. So that's it for this lecture, and in the next meeting we're going to discuss the tangencies but using the AutoCAD. We did it by hand, and we're going to have the exercise today. Then the next meeting we're going to repeat the tangencies but using AutoCAD. I'm going to show you how we can do it using AutoCAD. Then we're going to have an exercise as well. Thank you, and see you in the next meeting.